Okay, this is a PowerPoint that I put together in 2019 to debunk the IPCC agenda on climate change. And it's over 100 slides. I've always wanted to upload this to my YouTube channel, but because it's lengthy, so you can get the hair off, because it's lengthy, I've just had issues doing that. So I'm going to go ahead and try it here. I'm not going to stop and redo it, whatever. It's going to be raw and unfiltered. So we'll go ahead and get started here. Let me put this on. Okay. So to begin with, I'm going to try to crop this so you're not seeing my baseball glove on top or anything like that. And it's better visually for you. All right. So the first slide, and again, this is how I see the climate hoax. Number one, it is driven to change the global economy. That's the entire purpose of what the IPCC is doing here and what they have been doing for decades now. So to begin with, on this first slide, on the upper 12 o'clock position, we'll start there and work our way clockwise. So the legitimate side of climatology is that Earth is in a Holocene interglacial warming period. The Earth is warming. It's not the first time that we've warmed and the planet has lost its ice. And after this occurs, we will go back into an ice age. It's all part of a cycle. And I believe that this is the sixth cycle in the proxy record. And we're in the Holocene interglacial warming period right now. So what that means is we are naturally warming. Yes, we are warming, okay? But the question is, what is mankind's contribution to that warming? And we'll get into that as we go along. Now, to the right of that is the raw temperature data. We have records that go back 150, 200 years. Next are the natural cycles involved. Again, these would be the cycles that put us into ice ages and also put us into warming periods. And then beneath that is the CO2 role. What role does CO2 have as a greenhouse gas? Now that is being perverted by the agenda. On the illegitimate half of this Ouroboros snake that is consuming itself is the IPCC agenda. And that's fueled by false claims. It's fueled by a huge warming bias within the network of global thermometers and also altered data. So to make it look really bad, they had to alter some of the raw data temperature records. Okay, we'll begin with looking at some of the false claims here. And I literally have, hundreds of these. So what is a false claim, right? Focus on the blue area. Manchester's all-time record is 103, set on July 22nd, 2011. So here we go to the National Weather Service database, and we go to the Manchester airport, and we see that, yes, in 2011, it was 103 degrees Fahrenheit. However, that station is missing 43 years of data. But if we look at Manchester and the surrounding area, it tells a different story. Now, the purple dots on the left, the upper purple dot is Manchester, and that's the airport location. But, well, no, that's actually another location in Manchester that I'll talk about in a minute. The below three dots are geographically close, and they have weather stations. So within that same region, but not within Manchester's city limits, you have Nashua down on the bottom. And in 1911, that was 106. In 1948, is 105, definitely above 103. And then you have Windham. In 1955 was 103. And the airport purple dot is the one in the center there. I apologize. And that's the one in 2011 that was 103. Now, the upper purple dot is within the city limits of Manchester. And that's a location, Massabesic Lake, And we'll see that in 1988 it was 105 degrees. So if you look at Massapequa Lake on top and the Shua on the bottom, I'm going to compare those two for a reason here. But if you look at the highest max temp in 1988 on the upper graph, that's a heat wave. Okay, that's not increasing intensity of temperatures. Okay, so why am I comparing both these? Well, we're going to do what they do. They homogenize records. So we're going to do the same thing here. And homogenizing is when you compare two stations or more and you try to get an average. And so at the upper graph is Nashua and the lower graph is Manchester Airport. Now remember, it was missing 43 years of data. But if we look at comparable years, we see that from 1998 to 2017, the airport location typically runs about 1 degree higher than Nashua. And what does that tell us? Well, it tells us that the Nashua record in 1911 was 106. So it could have been 107 at that Manchester airport location. We don't know. It's an airport. That's a man-made, it's got a lot of asphalt and concrete. So, we don't know. But today, we could speculate that, it's probably about a 1 degree higher. So this is enough information to debunk that claim. False claim number 2, Anchorage was 90 degrees on July 4th. In the blue area down there, the temperature at the airport was 90 degrees on Thursday, besting a 1969 record for the highest mark ever recorded in the city. So let's debunk that. Okay, this is the Ted Stevens Airport, and we see that to the far right that it did, in fact, reach 90 degrees. And you see the temperature record for the highest max temperature ever since that station has been in operation from 1952 to 2019. But there's more to the story. So if we look at the city limits of Anchorage, again, that includes Merrill Field. So let's take a look at the temperature in Merrill Field. In Merrill Field, that has been in operation for much longer, although they didn't report temperatures for quite a period there. But we see in 1915, it was 100 degrees, and in 1931, it was about 94 degrees, 92 or 94, 92 degrees. So the red line there, I put that there so that we could see when the temperature actually exceeded 90. So we can see in the past that no, within the city limits of Anchorage, it has been hotter in the past. Now explain that. Okay, it wasn't CO2 in 1915. Okay, false claim number 3. France endures its hottest day ever as Europe swelters in a heat wave. So here they're pointing out a town called Galarges-les-Monteaux. That's in the southern area of France, and that hit 114.6 Fahrenheit. So let's take a look. Now, if you go to their climatology website, yes, we can verify the record did occur. So we verified the data. Interesting thing, though. See this right here? They show the location. Let's take a look at that location. That is mounted on top of a tile roof. Okay? And not only that, this is an automated weather station that has only been in service for 15 years. I don't know exactly when this particular one, but all the AWS in France are only 15 years old. So when they installed that, I don't know. And of course, we're talking 2019, so it would be 20 years now. So tile, when it gets hot, it radiates heat upward. How much did that skew the record? So when we look on that date in this period, it really becomes a tale of 8 stations because they have more stations reporting today than they did in the past. And at best, it confirms a heat wave, but it does not confirm a new heat record. You can't, we know heat occurs every summer, right? So you can't infer by missing data that is all-time high, the way that they word that and say that. So, this is their metro office there, just a little history, established in 1993. That particular station and AWS in general in France have only been operational for the past 15 years by this company. And now let's look at the region. Okay. And there is a question that I can answer. Did AWS replace 12 existing stations, or are these 12 new sites? Well, we don't know. So the red area there is the region. And before I go any further, I just like to use an analogy of earthquake activity. So here we see in 1960 a huge spike in earthquakes. Okay, when you look back in the historical record, you're like, whoa, what's going on here? So you could okay, let's try and find a cause. So you start looking at correlations, not as a cause, but you want to, dig into it. So here I found oil extraction. Oil consumption equals oil extraction. So you're pulling all this oil out of the earth. Is that somehow causing earthquakes, right? It's like people say, well, fracking is causing earthquakes. Well, no, it's not, But anyway, this is just for illustration only. So we do see a correlation between oil consumption and increased activity of earthquakes. But when we dig deeper, we see that they simply added more seismic centers globally. And that system came online in 1959, 1960. And after that, they started detecting a whole bunch of earthquakes. Okay, so if you were to look at this as a thermometer versus a seismograph, do you think that if they had fewer thermometers in the past and they have over 9,000 today, that you're going to detect more heat records? Yeah, sure you are. So getting back to, this is, just more on that. Okay, more thermometers equals more heat records. I think that's obvious. So the region of Galarges-Lee-Monteau falls within a subtropical zone. And that zone is indicated here in green. And the region gets very hot and routinely exceeds 115 degrees Fahrenheit. And here's a map depicting that. So you can see all throughout in Spain, 1946 is 116. Morocco routinely hits 120 plus. Libya in 1931, Tunisia, 1931 hit 131 degrees. And then you have just other areas in this subtropical zone. Okay, so as far as a climate zone, it's not breaking any records. And these are just past newspaper articles that discuss other heat records in the past. Okay, that's called data. It's called raw data, raw temperature data. Okay, so false claim number 4. July 2019 was the hottest month on Earth since records began. Okay, that's interesting because records have been around for a long time, since at least 1850. So if we read this below, it states that, again, July was the hottest month ever recorded. And then I believe it might give a location. If not, let's go to the next slide here. So this is disingenuous at best to state that. And the reason is, in 1880, you only had 277 stations reporting into a network that were eventually would be tied into GHCN in order to determine what the temperature was back then. In 2020, that had grown to 9,000 stations. So it's very disingenuous for NOAA to state that, especially since most thermometers, you can see that the United States is solid red, right? But you have these heavily populated areas where you have other factors in play. You have urban heat island effect. And they also, if you look at Greenland, that's very interesting because there's almost no thermometers on the interior. They're all coastal. So all they're doing, all these coastal stations are just picking up ocean heat. That's all they're doing. Well, ocean heat is not CO2. Okay, CO2 is not making the oceans hotter. There's a process involved where you have CO2 does radiate heat, okay, but that is a regulator. It doesn't increase heat. It'll keep, it has the potential of warming temperatures at night, right? So it'll make it slower to cool off. But there's a huge unknown factor, and that's called clouds. And there are no good cloud studies that show how much heat is being retained by clouds. Okay, and you also have smog in cities that has an effect, everything. Anyway, this just illustrates that, yeah, that's a disingenuous claim by NOAA, and they know it. Along with this, the claim, they state that the Swedish hamlet of Marcus Vinsa recorded 34.8 Celsius as the highest temperature measured north of the Arctic Circle. Well, it's simply not true. But let's go ahead and just look at this, right? So I've circled here in the box, confirming the record. Yes, that did happen. And then below that, in the same region of Norrbotten, it was much hotter. It was actually 36.9 Celsius in 1945. Now, how much CO2 was making that happen? Again, this is evidence of a heat wave, not increasing intensity. So you see that little dashed line? That's the Arctic Circle. So you might say, well, they're still right? Arctic Circle? Well, no, they're not. If we look at Alaska, they've recorded higher temperatures in 1999, 2004, 2009, and 2012. So, see if I can shift this over this way. There we go. So, no, it's a bogus claim. Okay. It is evidence, again, that we are in an interglacial. Things are getting warmer. But if you're going to, right, the reason they distort these claims is they want to instill fear, like, oh, first time ever, right? So this is a look at the Alaska stations. And again, you can see these spikes here. So that's just indicative of a heat wave. It's not indicative of increasing temperature. Let me go back. So you can see, like this line here, it's not like going up. Okay, it's fairly flat heat wave. Okay, another claim, Earth is warming faster than ever before. Well, simply not true. When you look at the proxy record of Greenland past 12,000 years, you can see this period all the way over here, about 7,500 years ago, the temperature increased 3.57 degrees Celsius over a 320-year period. Now today, it's increased 3.47, which is beneath that over a similar number of years, 306. So it's not warming any faster, and I doubt CO2 had anything to do with this right here. Peak of the Roman warming period is actually higher, according to the proxy record, than today. Okay. Another thing you hear is, false blame, right? So they blame everything. Since 1950, humans are the sole cause. And that's what this says. Human activity, human influence is clear, but there's another one that says that and I'll get to that slide, that humans are responsible for all the warming since 1950. So if we look at, it says here, since the 1950s, changes are unprecedented. So we're going to say, okay, is that really true? So we're going to go to the wildfires report, and you can see on the left, 1971 to 2000, and what they projected 2041 through 2070 to be on the right. Okay. Well, let's get into the weeds on this. If we look at the 1995 Federal Wildland Fire Management Policy dated January 2001, okay, we're going to dig into this. We're going to see here that that's simply not true. Now, I'll just go ahead and read this whole thing. In the contiguous United States during the pre-industrial period, an average, and that's 1500 to 1800, an average of 145 million acres burned annually. Today, only 14 million acres are burned annually by wildfire from all ignition sources. Now, the important part is land use change, because we know that we've developed, and there's been a lot of deforestation and stuff like that. So, and just human activity, right? So if we continue, this is land use changes such as agriculture and urbanization are responsible for 50% of this tenfold decrease, right? So that means that you have fivefold that you have to explain. Okay? Land management and actions, including land fragmentation and fire suppression, are responsible for the remaining 50%. So let's take a look at that fire suppression. But before we do, I've got a slide here. I'm sorry, I didn't memorize the order here. The alarmism on that information is the cherry-pick graph by Climate Central. And what they did was they went to the National Interagency Fire Center. They cherry-picked from 1970 to 2015 to show that more acres every year are burning. Okay? Well, if you look at the full graph from the agency on the bottom, they conveniently left out everything before 1970, where you can see that huge increase that the fire report mentioned, 145 million acres a year. So when you put the land change, okay, you still have a lot to account for, and that comes to fire suppression. So let's take a look at fire suppression. Okay, here we go. So there's a history of wildfire suppression you can pull up on Wikipedia. But burned acreage since 1970 has increased due to let it burn policies. Okay? So they're not out there aggressively going after these fires. Then when the Forest Service came online, that's what they would do. They would send fire jumpers, and they had fire lookouts, and every time they saw smoke, they would just attack it. Well, that changed in the 1970s, 1978. They abandoned the 10 a.m. policy in favor of a new policy to let it burn. Basically, protect the areas that had human, interest, economic interest. So, communities and things like that. Okay, another bogus claim here. Amazon rainforest. This is Yahoo News. Amazon rainforests that were once fireproof have become flammable. Okay. They were fireproof. Well, let's dig into that. All right. They blame CO2 and everything like that. And CNN, Brazil's Amazon rainforest is burning at a record rate. Okay. So here we have the data. And in 2017, it was 196K. And why they did not reflect that, I don't know. But we're going to see as we go in what the real deal is here. In 2004, there was a record 270,000 fires. 2017, that number was 196,000. In 2019, it was 75,000. So what they're saying is simply not true. You can go in, they analyze that, and there's two things going on here. Number one is a technology change. So JPL created technology where they could look at understory fires. And it's a innovative satellite technique. So I've got an infograph here. Actually, I think if I hit this, yeah, there we go. So with the technology since 2013, they can detect a lot more fires. Okay. Whereas, and now they can actually count them, right, in greater numbers. Since 2013. So let's go into the history of the Amazon. There's this 1985 study that you can pull up online that documented they went around, they dug test pits, they were looking for ash layers, and they did that. Numerous Amazon fires have occurred over the past 6,000 years. Okay. Past climate dry phases may have destroyed a large area of the Amazon. Okay, and then there's another, the fire ecology in tropical rainforests should now be considered in both an ancient and present day context. So they've never been fireproof in the Amazon. It's never happened. Okay, everybody freaks out when the Amazon catches fire because they have this impression it's a tropical jungle with 100% humidity. Why is there fire down there? Well, that's simply not the truth. So JPL also did a study, and what they determined was that Amazon fires claim up to 50% of Amazon trees, and the remaining 50% survive. And that's really a good thing because that means regeneration of the forest that occurs very quickly. Let's take a look at that. So Brazil comes up with a plan, and they say, they thump their chest, because they're all climate activists, and they say, we're going to plant 73 million trees, and we're going to, really knock a dent in what CO2 is doing to our planet. So if you look at the bottom line there in green policy, 14 years to restore 12 million acres of degraded forest from 2016 to 2030. That's their goal. Okay, nice goal. But if we look at a UN agency called Input, they did a study, and this is what they found, that natural regeneration is the lion's share of Brazil's policy goal. In fact, you'll see how much. On the right, 7 million hectares of natural regeneration will occur over a 10-year period. That equates to 9.8 million hectares over a 14-year period. In the bottom line there, 82% of Brazil's policy goal is natural regeneration. Okay, well, they're still able to add 18%, so I admire them for that. But they don't say anything about natural regeneration. They take it on as, we're doing it, right? Well, no, you're not. Mother Nature's doing it. Now, there is a problem. Now, Input, the UN agency determined that they're not calculating regeneration, and it's a problem with the technology. The technology does not go back and look at regeneration. It will take a burned area and keep it burned, right? So it doesn't go back and 5 years later and say, oh, well, this is regenerated already. So when you look at the numbers, when you include regeneration, it should be about 25% less. So if you go on now, they say a total rainforest loss is 792,000 square kilometers, right? Well, it should be 595. And all of that is being regenerated, okay? So if they include regeneration, eventually that 595 is going to be cleared up. You'll have new burned areas, naturally, but that's just a cycle. So they looked at the satellite, and they saw a problem. And the thing is, they recommended in the conclusion that Brazil and the IPCC take regeneration into account of the Amazon rainforest. And guess what? They're not doing it. Why? Because it counters the narrative. They want everybody to believe that only man can fix that problem. So let's go plant 73 million trees. Because if they said, well, maybe we don't have to do that because Mother Nature is going to take care of 82% of our policy goal, you're not going to get that much interest, right? So there is a reason why they don't say anything. Okay, going on to false claims to total nonsense. I like this one here. Global warming is putting the ocean's phytoplankton in danger. And it's polar bears, it's whatever. These are just examples that I'm showing you of many. It's ticks, it's whatever, right? Phytoplankton adapts to changing ocean environments. So if you go to this study at PNAS, the reality is some plankton can rapidly adapt to acidification. Acidification is another thing, right? That's being blown out of proportion. So what does the research say? Well, I'll go ahead and read the blue area. They looked at data the past 50 years. They found that phytoplankton from the North Atlantic has thrived. In fact, its population has increased almost tenfold since 1965. That's not supposed to be happening. The oceans are turning to acid. So I put together this very confusing chart that I'll try to explain here. So if you look at the pH, let's start at the top. There's the inverse relationship with CO2, ocean pH. So if we look historically at the top graph, in the blue triangle, 7.5 pH intersects with a purple dot, okay? So let's take that blue line and let's go all the way down to the middle graph, or not the very bottom on the right, but the middle graph. And we see that 7.5 was at a time when CO2 was about, you got to look over here, when CO2 was about 3,000 ppm, right there, okay? So during the Jurassic, the CO2 was 2,000, and the ocean pH was 7.5. Okay, so if you look at let's go back up to the top, that purple dot to the left, the purple line, follow that all the way down, and that intersects. And again, you can see that the ocean pH then was a little higher, 7.6, I believe, and it was just virtually identical as far as the phytoplankton is concerned. So on the bottom, last time CO2 was at 980 ppm, the temperatures were about 22 Celsius, and the ocean pH was 7.7. That's what that purple line represents. But look at the plankton species, right? That is the top graph. You can see that they were thriving. Okay, so you do have phytoplankton thrives, and it can do so, as the study suggests, very rapidly. So there's been no loss or no hits on phytoplankton. And the lower right is just the projection of CO2 out to 2100. They project it's going to be 980 ppm. Even if it gets up to that high, phytoplankton are going to be around. They're not going anywhere. Okay. Again, more from the study. After 45 days, they evolved with increased growth rates. Okay, so this is when they stressed out the phytoplankton with temperature, and phytoplanktons, shook it off like, hey, no big deal. Okay, more false things that we hear. I got to talk about the glaciers because, again, we know there's melting. Okay, but the way they put it. All right, so here is a 1939 article where they had a rapid melting event. And this is at it's a Swedish geologist. And they described a catastrophic collapse of Norway's glaciers that was observed prior to 1939. Okay. Again, it goes back to since the 1950s, changes are unprecedented. Yeah, around the turn of the last century, changes seem to be unprecedented. So when you look at the Nygaardsbreen Glacier, this glacier is well documented, and they go back all the way to 1748 actually, when they started keeping records on this glacier. So let's just take a look. Now I put all the red stuff in here, and I wanted to document the retreat of the ice over time. So the catastrophic period that was mentioned in the previous article was 1845 to 1873. And you can see this red area here, that much ice was lost over a 28-year period. Now, when you go from 1937 to 1964, over 27 years, that much of the glacier retreated. I mean, that is fast. That's a lot of warming from 1937 to 1964, okay? Very few cars on the road during this time. Well, it's slowed down quite a bit since 1964, okay, all the way up to 2019, over a 55-year period. It's like it's hit the brakes, right? So if the argument is CO2 is causing glaciers to melt faster, you have to explain this, okay? And other areas as well, Now, the counter argument is, well, that's in one area, It's not a global thing. Well, nothing is in a bubble, all right? And since you're not talking about a month or a day, you're talking years and decades. So I would say that over that long period of time, this is an accurate reading of what temperatures are doing within those latitudes and longitudes. All right. So, one more thing. So on the right here, you can actually see from 1873 to 1950, 77-year period. And then from 1950 to 2019, it's actually slowed over a 70-year period, right? So it's retreating at a slightly slower rate. Funny, interesting. Okay, since 1950s, changes are unprecedented. Well, then they have to explain the first half of the 20th century. When they use the Michael Mann graph wrongly, because even Michael Mann put this on here. The gray area is your area of uncertainty. So if you were to, and they lowballed it, right? So if you were to like put it at the top, there's nothing is wrong, right? But they don't, because they have an agenda they have to push. So just by looking at the data, their claim is very doubtful by looking on the chart on the left. But when you look on the right, you can say it's false, because now we're going over the past 10,000 years, we're using ice core proxies. It's a very busy graph, but in effect, you can see that 2016, which was the hottest year back then, you can see that it fell well below the Roman warming period and the Ionian warming period. And it's not an exact measurement. It comes out to about a 1.3 Celsius like area. Oh no, here we go. The range is 0.63 Celsius. It's kind of small print from where I'm at. So, and that's based on the Berkeley data. That's the lower metric. And JISP 2 is the upper metric. So somewhere within there is the actual range of temperature when you look at their proxy data. So, but again, it's well below the Roman warming area. Over the past 10,000 years, now it's not. And you can see that they have rapid ups and downs all the way here. And in fact, if we didn't start using CO2 as a regulator of temperature, right, we'd be an ice cube right now. And this takes this chart all the way out here to GHCN is what provides that data. And those are those 9,000 thermometers that are positioned throughout the globe. Now let's talk about that warming bias within their network. There's a sparse interior coverage in underdeveloped global areas, and we're talking northern Sweden, we're talking Siberia, we're talking Greenland, we're even talking our floating ice cap up north. They don't have stations up there. They're all located on the coast. And the coast, you're going to be getting that heat that is coming out of the oceans. And where does that heat come from? Well, it comes from the equator. So, there's a whole big network of how does heat get up there to make Alaska so warm, right? It's not coming from the air, okay? It's coming from the ocean. So there are sparse to NES stations on the permanent ice cap in interior remote regions, and they've dismissed long-term station data in Sweden. And coastal stations only add to the warming bias in all these populated areas. So this is there was a developer website for GHCN version 4. And on their database, this is a interactive globe. You could spin it. It's pretty cool. But when you go over to the coldest region in this area of the world happens to be northern Sweden. There's about 7 or 8 stations up here that are long-term reporting stations, and they're not in the system. Why? They're all on the coast where it's warmer. Okay, they have one on the interior here, but it's not in the coldest region. Okay, again, these are in very warm areas along the coast of Norway, everything like that. But let's look at what that's just not me saying it. That's a developer saying it. Okay, so you could read through the purple here, but I'm going to focus on what Olaf has got to say. He says, I am slightly disappointed with GHCN version 4 in my country, and he's Sweden. There is still no coverage in northern Sweden, for instance, and I know that there are 8 stations in the area with almost unbroken records going back to 1860. GHCN version 4 does not have the best that we have. But I guess that it doesn't matter from a global perspective. So he's dismissing all of their cold records, right? That's the coldest part of that area, and it's not in the network. And why is that important? Well, they average all these temperatures to come up with the average global temperature. And if you're purposely leaving out the coldest regions, what is that? It's a warming bias. Okay, but they go on and say, well, we've solved the Arctic cooling bias. Well, sure you have, because you've taken out all the coldest regions, right? All right. So northern Sweden is colder than northern Norway during the winter months. Again, it's, they have the coastal stations, but they don't have the interior region. These are the locations of those stations that Olaf is talking about that are not in the system. And then you have the ClimateGate emails. I'm not going to spend time on this, but there was manipulation of data, and we'll get into the manipulation of data. So they talked about a blip, okay? And the question is, did they lower the 1940s blip? Well, yes, they did. So when you pull up these areas here, this is Reykjavik, Iceland. So you can see, let's start with the lower left, because they track what they did here. So if you look at the greenish pea-colored line, that was the original raw data. Their blue is their homogenized altering. So they went and made it very cold in the past. So if you imagine that blue line not being there and just focus on the pea green line, there's not much of an increase in temperature. So to make it appear that temperatures are getting much warmer, they had to go back and make the past cooler. And that's that 1940s blip that they're talking about. So if we compare the unadjusted data with the adjusted data, and I put these lines here, we can see it's huge. Okay, so here you have no cold temperature below 3.5 as the nominal. Okay, but now it is. It's full, right? So, and then they made it warmer here when it wasn't. Or no, they took away the warmth. I'm sorry. So this is the raw data. This is homogenized. Okay, and that's how they make it look like temperatures have been warmer. But if you look at here, no, they're not. There's nothing unusual here. Okay, all within range. And it's not just Reykjavik, it's other locations. So here is the U.S. historical raw data, and we're going to start with Hansen. So you have Hansen over here in 1999. This is his chart. Hansen revised his chart in 2001, and then we have GISS in 2018. And we're going to compare all these. So I lined them up, and this red line that intersects and goes through all the charts and graphs, you can see clearly what they've done. So they've erased the warming period here. You can see the box that I put. That's no longer here, okay? And even in Hansen's modification, he lowered it himself. So they removed the warming to make it appear as if today is getting warmer. And they did that through a process of homogenization, right? So they took raw data and said, well, no, that can't be right. Let's get surrounding station data and let's average it all out. And that's how they made these changes. They found a way to lower the temperatures. Okay, the effect of altered U.S. historical raw data is that now U.S. temperatures have risen faster since 1950. And that's the entire objective, because that's what the argument is. Changes are unprecedented since 1950. And now we can prove it with our altered data. That's exactly what they did. Okay, there's something else here. This is Hansen. And NASA Earth Observatory on the left, they cite that Hansen 1999 chart. And this is what they say: the first reliable global measurements from temperature from NASA. So reliable, right? That's Hansen's chart. That's reliable. So what we're going to do is we're going to superimpose what Hansen did over the projected temperature increase. And when we do that, they really corrected their problem, because when you look at the homogenized global record, it now exceeds Hansen's prediction. See what they've done here? Right? So they've really made it hot just by homogenizing the record. But they solved that cooling bias, didn't they? Okay, so, we already talked about how they lowered the past and they've elevated the present. Now let's focus on elevating the present. This chart on top is Hansen, and the red dots just correspond to years. So you can see what the global average has been from 1850, back when they had 277 thermometers, all the way up to 2018, where they have over 9,000. And this is how they've, again, like earthquake activity rising, you have a lot more sensors here, right? So you're probably going to detect a lot more heat, okay? Now we're going to look at the comparison of temperature with CO2 and take a look and see what they did. Now, if you look at that, and let's keep in mind that NASA stated that the first reliable temperature record was Hansen, that Hansen graph, the first one that he did. So if you look at the unaltered Hansen 1981 graph, and you put the CO2 ppm, which is in the green line, and you can see it clearly here, right? But this is just, it's the same thing, okay? That goes up to 1980, and then this projects it outward. This is CO2 right here, and temperature. So what they've done, there's no correlation here, right? Well, by adjusting and lowering the temperatures, now when you lower these temperatures, now they are just like, they follow each other. So let's go ahead and take a look at how sweet that is. Now it's perfect correlation. They manipulated the temperature data to get this. Okay. I got to plug my phone in here, so I'm not going to stop or anything. My phone's battery is getting a little bit low. So let's see here. Maybe I could do it right here. Boop. So I'm going to have to do this real quick. Okay. All right. Let's see here. I think, okay, yeah, I think that's good enough right there. Okay, so that's what they've done. They altered Hansen data to show a correlation between CO2 ppm. Now, CO2 and temperature over the past 11,000 years to 1950, this is a temperature cyclic waves, and then below we have the CO2 wave. And this is going back 450,000 years using the Vostok ice core temperatures. And here we can see these, the correlation between CO2, where temperature here, CO2 is pulling up temperature, and then CO2 always lags temperature. So now they've tried to reverse that. They're saying, well, no, now CO2 is causing temperature to go up, right? So in other words, temperature is lagging CO2. And that's just not what the record shows. This is another chart that I put together. This is just to show that when you base the global mean on ice core proxies, and this is on an earlier graph. It was very small on the right. This is a breakdown. So you're able to look in the past based on ice core proxies and see really how our temperature today looks relative to how it was during the past. And you can see here that during the Roman warming period, it was warmer than it is today. Today, or at least in 2016, where the mean temperature is 14.87 Celsius on the upper limit, right? It could have been all the way down to the lower Berkeley range. So it's somewhere within this range, within a 0.63 degrees Celsius, error, that we're still, we have not hit the peak of the Roman warm period, and they didn't have CO2 back then, right? So, and there's other information you can extract from the graph, but I'm kind of trying to be quick here. This is Summit Camp, Greenland. They have a false record claim, 2.2 Celsius, July 2012 and 2017. And it was negative 63.3 in February 2002. When you look at their data, you can see this is what their temperatures are annually from 2008 to 2021. And this gives you a range. When you look at the range and you lay a red line on top, which I've done, so this is 0 degrees, we see that in 2013, it went higher. Now 1.2, so it's about 1.2 here as well. But when you look at the claim, what did it say? Hold on here. 2.2 Celsius, July 2012. Okay, it was 2.2 Celsius. So let's go back here. We see that in July 2012, it was not 2.2 Celsius. Hold on here. I gotta get this. 2.2 Celsius, July and 2017. Okay. So, where's the claim? I'm trying to find the claim. I apologize for this. Maybe if I read this here. Okay, yeah, here it is. So they say in July 2017, the site recorded the lowest temperature at negative 33. But it was negative 63 in February, and then of 2002. And then for the hottest, it says the highest temperature at Summit Station was recorded on 13 July and 20th, 2017, and it was 2.2 Celsius, right? So here we go, and we see that it was negative 66 in 2011, and it was 1.2. It's not 2.2. Okay, so that's the claim there. So it's 1.2 and not 2.2. But again, we had Greenland melting, right? So if you go back, you can see that the range, there's been heat waves up there, but they've only been recording temperatures since 2008. So we don't really have longevity as to how was it in the 1930s. We don't know. Okay, so I apologize for that, jumping back and forth. Single stations matter. No station operates in a bubble. And I wanted to bring up the Blue Hill Meteorological Observatory. Here you can see a slight steady rise. Again, Earth is in an interglacial warming period. And this goes all the way from 1893 to 2019. And this is the longest operating weather station in the continental United States, Blue Hill. So this is their record. right? So you can see a slight steady rise. I know I applied this to some metrics here. When you look at the mean average temperature, you can see the slight steady rise. Over here, the mean is about 48 right here. And over here, the mean is about 50. When you go for here, it's about 50. So that 2-degree rise is consistent with another location that I'm going to talk about. So here, close to where I live, I did the same thing. There's been a slight steady rise again. We see that at Blue Hill. These stations do not operate in a bubble. They both indicate about the same thing, and they're both on different coasts. So when we look at the highest max temperature, we don't see an increase in intensity. Now, the highest max temperature is recorded during the daytime at the hottest point of the day. So it's not getting hotter during the day. Now, if CO2 were having this effect of acting as a thermostat, which is what NASA says, it would be making daytime temperatures hotter, and it's not. Okay, the effect is at night, and we'll just discuss that. Now here we have the mean max temperature. This is the mean, and again, slightly going down. It's within a range. Nothing crazy going on here. Now here's the mean min temperature. This is the nighttime temperature, and this is where we're seeing a slight increase. Now this is where the CO2 does come into effect by radiative forcing, okay? But you also have cloud cover that plays a role, and clouds have not been studied. CO2, the radiative forcing has a life. It doesn't just radiate all night. So it's still, and that radiation is not targeted. Think of a sphere, and you have radiative forcing that is going in all directions. So at least half of that from a molecule is aimed, well, not half, but the lower part is aimed toward Earth. And then it hits other molecules and it radiates and blah, blah, blah. But as a greenhouse gas, it helps to moderate the temperature. Existing heat is all it does. Okay, so if we overlay the Hanford station, where we have the high and the low. So let's take a look at that again. Okay, here you have the mean max and the mean min, and we're going to go ahead and overlay those. You can see that in the path, this is the effect of CO2 right here, okay, of a greenhouse gas. You can see the effect. Here you had a very wide gap between the high temperature and low temperature, and you can see it's narrowed over time. And it got real narrow here, but now it's kind of like opening up again, right? That's the effect of a greenhouse gas, is to help keep your temperatures milder. But CO2 is about intensity. So when you look at the intensity, it's actually declined since 1915. And I measure intensity on days over 99 degrees Fahrenheit. And you can see clearly that it's going down. So when you look at the trend, on the left side from 1915 to 1935, the average temperature was 62.6. When you look at the far right, over the same number of years, it's 63.6. So there has been in our geographical area a 1 degree Fahrenheit rise in temperature. Again, that is consistent with interglacial warming. And if you expand this and you look at the global average, it's consistent 57% of the time, and that's expressed by the green dots and red dots. And if you look at the climate zone that we are in, it correlates 87% of the time. Now, I looked at San Joaquin Valley in California to look at the coolest years and the warmest years. And actually the coolest years that we've had have been 2019 was a very cool year as compared to 2015. Okay, so you can go through, we broke a whole bunch of records over here, and we set a whole bunch of records over here. So you have this warming and this cooling. which interestingly enough, and this is the area here, interestingly enough, IPCC has hijacked cold, and they also blame that on CO2. So if you have a cold record, that's because of more CO2 as well. So globally, 2019 should be a cool year with a 57% chance, but let's take a look at that. That didn't happen. And I believe the reason that didn't happen, it's 57% chance, so yeah, But also another reason is where are all these thermometers are located? Of course, we are recording higher temperatures. It's the network. So 2016 was the warmest on instrument record as of 2019. But that's based on the homogenized record, okay? When you look at 2016 in the United States, the blue dots in these different areas here, again, these are the bubbles, right? 2016 was not the hottest. Alaska was hot. Now, what's Alaska? That's water. That's ocean temperature, because all these stations are along the water, okay? So that's the release of ocean heat. And that made 2016 the hottest, see if I can get back here, because of where the thermometers are located. Okay, there's a huge warming bias that is built into the system. And those thermometers here in Alaska, they haven't been there for a long time. 2020 tied for the warmest year on record. And I call that predictable because, again, they solved the cooling bias. So how much warming has there been since 1855? Let's take a look. Okay, they state over here, they have a projection where it's going to be, but this is a chart that they used. And I want to get into, there's another chart that's coming that's going to break that down. Now, they like to say that all these agencies can't be wrong, and I say, well, yes, they can be if they're using all the same metrics, the same system. That's very suspicious to me right there. Okay, it's because they're using the same database. How much warming is real versus how much is manipulated? Okay, well, I go back to Olaf, and he says that they solved the Arctic cooling bias. Okay, so in 2015, which is when Olaf said that, the following year was the hottest year on record. Okay, do you see this? The developers of the network responsible for determining the global average a year after a guy from Sweden says, hey, why aren't you looking at the coldest regions in my country, right? And that they've solved the Arctic cooling bias, right? The following year was the hottest year on record. That's not a coincidence. Okay, study, humans have caused all the global warming since 1950, and that gets back to the previous chart, how much warming since 1855. Well, if we look at, here I'm just doing another correlation look at the number of vehicles, which represents CO2, right, out of a tailpipe. So if we look at from 1913, when the first car assembly line was built, all the way up to about 1950, there were less than 25 million cars on the road in the world. Okay, after 1950, there's been a 5,580% increase of the number of cars on the road, up to 1.42 billion cars in operation. Okay, so if you were to take the warming, and again, this is GHCN, right? Remember, they lowered the temperatures here. So if you were to take from 1950 all the way to here, all these cars really aren't making it go up, okay? So how much warming? Well, since 1982 to 2016, it's been about a 1 degree Celsius rise. But 42 years, you had no rise. Well, how could that be? Okay, so they call that the hiatus, right? It was very difficult for them to explain the hiatus. But again, this shows that there's absolutely no correlation between, and remember, again, I should have put the unaltered chart here with Hansen because these temperatures here would have been up here, okay? So how many cars really are responsible for this, okay? How much is anthropogenic? Well, they've manipulated the data so much, we really don't know. I think it could be 0.2 degrees Celsius, okay? Because you have to consider urban heat island effect, and I think we're going to get into that now. Reno, Las Vegas ranked as the fastest warming cities, okay? So if you pull up their data here, you can see what Reno, these are two stations and they're 8 kilometers apart, so you can see what their temperature trends have been for the mean average. Mean average, mean, okay? So the red line indicates the highest temperature, and this is the, yeah, so it goes, my glasses, I can't see the date here. I'm gonna have to zoom in on that. But anyway, this is their temperature over time. This breaks it down. Okay, so if you look at the mean average from 1970 to 1979, it's 49.45 degrees. And then you go on the tail end, you do the same thing at Reno Airport. Again, this is the mean average. From 2010 to 2019, it's 55.47. So that's an increase of 6.02 degrees since the 1970s. That's Fahrenheit. That's a large increase in temperature. If you look at Reno, the Weather Bureau office from 1930 to 1939, it was 51.88. Okay, so what you have here is you have the airport that's only been around since 1952, but when you go to the Weather Bureau office that was in operation in 1930, you can do the same average and get 51.88. So when you do that, that difference drops to 3.59 increase since the 1930s. Now, how much of that 3.59 is urban heat island effect? Well, there's a guy that looked at that. So without the heat island effect, Las Vegas has risen about 2.2 degrees Fahrenheit. And how Matthew Lanchonette, I found this guy, you can Google him, but what he did was he looked at the nearest, I believe there's a wildlife refuge, so he looked at their temperatures, and I believe, let's see here, which one is it? So yeah, he's got the comparison of Las Vegas versus the desert game range, and you can see that there's been in an area where they don't have that urban heat island effect, the temperature only went up. It went up about half of what it did in the city. So there's a huge urban heat island effect that they're aware of at the IPCC, but they don't really calculate it properly. So again, this rise is due to the interglacial warming period that we're in. So global oil consumption, right? I just put that and I overlaid it with the CO2. And you can see that here we had a huge spike over about a 20-year period, but there was no spike in atmospheric CO2 ppm. So how do you explain that, right? There's been a 1.2 Celsius rise, again, using their data, their homogenized data, since 1950. And that's the global average temperature. So 1950 is the center line, and when you calculate it all the way out, it's a 1.2 Celsius rise. Now, when you look at their climate modeling predictions, a rapid 4-year rise at 0.4 Celsius right here. And the red dot is 2016, I believe, right? So that's a rapid rise right there. And again, this is just based on modeling. It's not based on raw data, right? So cloud effects, there is a apparent correlation, but there's not enough studies to determine one way or the other. But there's a definite correlation here. If you look at tropical cloud cover, and then you look at the global surface air temperature, it seems they're inverse to one another. So there is an effect that clouds play. And clouds are very hard to figure out because you have different altitudes and different types and what they do. And but that throws a curveball into all of this, actually, is what it does. Low cloud cover controls the global temperature. This is a abstract. No experimental evidence for the significant anthropogenic climate change. So here they looked at clouds and they determined that low cloud cover was responsible for climate. But the IPCC rejects that. Obviously, it doesn't fit into their narrative. So more information on clouds. I'm not going to spend time. Singapore is getting hotter faster. I believe there's a reason for that because of the cloud correlation here. Singapore is on the equator. Okay, a lot of water. They have a huge urbanization effect. So if you look from about 1980 all the way up to here, Singapore is like a concrete city. And before they had a lot of jungle. So a lot of people don't know that. It's really developed since that time. Okay, this is the Arctic and Antarctic trends. Northern hemisphere warming due to ocean heat release. And again, you're getting all that heat along the equator, and it's transporting along the conveyor belts and releasing heat up to those coastal stations. So when you look at the Arctic and Antarctic ppm, okay, keep in mind that, what they say, CO2 has a radiative effect, so that should be a global phenomenon, right? It can't, because molecules are distributed equally throughout the atmosphere. So you're going to have 405 everywhere throughout the world. So when you look at the upper graph, which is the Arctic, you can see what their temperatures are doing. So you have a slight increase since about 1997 above the red line here, being 0. And then when you do the same thing down there at the southern part of our planet, it's the South Pole, Antarctic. It's not really doing anything. Okay, so you can't say that radiative forcing is causing ice to melt and causing all this stuff when it's only happening on the northern part. And the reason it's happening up there, again, is they have the ocean conveyor. Let's look at this. There's no ocean heat going down south, right? Now, they do have volcanoes down here that, in the Antarctic that release heat, right? But that's, that probably pales in comparison to the amount of heat that goes through the conveyors. And that's why you get this right here. And it's not happening here. So atmospheric CO2 has nothing to do with warming, okay? Again, it's a regulator, it's not a controller. It regulates existing heat. And where do we get that heat from? The sun. Okay, so IPCC and NASA say that this is what we should worry about. Again, this is their thermometer controller that they have on the NASA website. And they want you to believe that CO2, you can just turn the knob, you can lower CO2, and your temperatures on Earth are going to drop, or you can raise CO2 and it's going to get hotter, okay? This is their carbon cycle. We pretty much know it, but if you put their little thermometer controller, that's the percentage that they're talking about. Well, you have a whole bunch of natural processes of CO2 and methane and all these greenhouse gases going into the atmosphere. And you have these ocean sinks and the carbon sinks and, but everything is due to man. I don't think so. I'll buy the urbanization. CO2, yes, but not to the extent that they claim. Now, let's look at the positive benefits that are never discussed of CO2. Well, CO2 is greening the planet. There's enormous fertilization going on, and there's a study over about a 30-year period. 60% of anthropogenic CO2 is captured by carbon sinks, resulting in a net positive effect for the planet. So they went over a period of time, and they determined that there's just a huge, from 1982 to 2015, that the Earth has greened the equivalent of adding 2 continents 2 times the size of the mainland USA. That's a lot of greening. And this is going from 338 ppm to 398 ppm. So, I would like to see the study current, because the Earth is getting a lot greener. And what does that mean? That means more life, more bugs eating the planet, the plants, and there's more. It's good. A green Earth is good. So CO2 is fertilizing the planet, and again, it's all part of the cycle. So ppm effects on human health, you can take it all the way up to 2,000 ppm and you're fine. I mean, astronauts in space and submariners breathe high amounts of CO2. And here, you can see that plant growth, it's got to be 150 ppm. The space station limit is 5,000 ppm. And then submarines are 8,000 ppm, right? And where are we at? We're at 420 ppm. So, it has no effect on the human body. We are made out of carbon. Carbon is our friend. So here we go. Ask a climate scientist. I should have had this slide up earlier where, lagging CO2. This guy just says that, well, now CO2 is causing temperatures to go up. So temperatures are lagging CO2, where in the past it really hasn't happened. I think that what I have here, I think that likely both processes are occurring, where you have the interglacial warming period and you have the anthropogenic inputs causing the warming that we're seeing. So this is an interesting chart here, produced by a guy, Scotty's professor, and we are living in an icebox, 14.73 as of 2018. Now, when you get up to 15, you move into a new, climate zone is how they have this broken out. But over time, now we're right here. So he projects that we're going in this direction, right? Well, he's not wrong. Now, in other areas, you can see this is a meteor hitting Earth, ice age, right? But here, he believes that CO2 is going to do a rapid rise like that. Well, there's nothing in the proxy record to indicate that that's happening. But, Scotty's is on the side of the IPCC, but his chart. But he does have a good chart here, and this is where we are. We are a cold planet. That's what we are. So when you take Scotty's chart and you adjust it, and you use the proxy record, you can see that today temperature is running above CO2. Okay, this is just the El Niños. Again, these are part of the cycles. And you can see during very strong, you have these spikes, these heat waves that go through. El Niños drive heat waves. Now, the role of CO2 on Earth, CO2 radiates solar irradiance. CO2 aided by clouds creates climate conditions, creates our climate and our weather. CO2 fertilizes plant life, and the warmth potential is regulated by solar irradiance to support carbon-based life. And we don't really hear any positive things about CO2 from people that want to destroy it. Carbon neutrality is a sin. It's an evil against nature. It's an evil against us. Water vapor is the dominant greenhouse gas. They never talk about that. So the blue slice here is water vapor, and that does have a greenhouse gas effect. And then you have all the other ones, including CO2. CO2 is 0.013% is responsible for skyrocketing temperatures. I mean, it's just so ridiculous, you know. Really, seriously, that's that thermostat right there. It just does not hold water. Now, the agenda is what's driving this thing. That's the head of the Ouroboros snake. And this is their agenda summarized. The petrodollar is blamed for global inequalities, poverty. So they want to change the global economic system. Oil is cheap, and peak oil is too far out for a natural shift to emerging technologies. They want to rein in the American lifestyle. That's consumerism. They want to tax our carbon footprints to aid poor countries, and they want to implement UN Agenda 21. And that is just the control of global resources. So changing the global economic system is the primary goal here, because they want to get away from American dominance in the economy through central banking. So when you destroy the petrodollar, you've done that. And we're seeing the effects of it now, the rise of the BRICS. They're basing a new digital currency and currency trading system on gold. So that's very attractive to countries that want their currency to be based on something. It's not based on anything in the United States. Oil. But what are we doing to oil? We're killing it. How petrodollars affect the U.S. dollar, you can read that yourself. Okay, this is AOC Chief of Staff confirms that the Green New Deal was not about climate. Of course it's not. It's about changing the global economy. This lady right here, who was the Figueres, if I'm saying her name right, who was the head of the IPCC at one point, stated that it's about changing the global economy, right? So that's the name of the game, right? And then she's so backwards in her thinking that she, during the Obama administration, came out and said that China was leading the way. Well, China's not leading the way. When you look at the CO2 emissions, China's 30%, the United States is 15%. So tell me, where does that fit? Well, I'll tell you why. Because America, the petrodollar. China is not the petrodollar. So the IPCC impact on future generations is basically green energy is very, I don't like they call it green energy because it's not. Green energy is CO2. That's what green energy is. So all of this, solar, wind, electric, is very expensive, very expensive. So this is their Agenda 21. I'm not going to go through it. It's all about sustainable development, how they want to put us into 15-minute cities. So the Supreme Court ruled that CO2 was a pollutant, but Alito, the common sense guy, said, well, no, it's not. Basically, they had to regulate CO2. That's why the Supreme Court stated it's a pollutant, so that the EPA could regulate it. It's just a legal maneuver. So Earth is carbon-based life, right? We know this. World leaders are told they must act over climate change because we're over the cliff edge. They say that every year. Countries that joined the Paris Climate Agreement. Now, Trump took us out, but, we're back in. So, the whole world is hoodwinked on this thing. I don't see, pulling back from it. It is what it is. More fake news. Arctic summer is going to be ice-free by 2013. The Maldives are going to be submerged by 1 meter of water. A call for greenhouse action, blah, blah, blah. If you don't do it, the world's going to go away. Well, the reality is, let's just look at the Maldives prediction. They said that by 2018, there would be 1 meter of ocean rise. In reality, it was 4.3 centimeters. Okay, so there's a lot of fear. Again, they don't want you driving automobiles. They don't want you buying. They don't want you going to Walmart. You know, they want to reel in your consumerism. This is the Arctic summer in 2020. And I think that goes back to the claim that there wouldn't be any ice. well, that's the ice that was there during the summer, right? If you tell a lie big enough and keep repeating it, people will eventually come to believe it. So 2020 was tied for the hottest year, again, based on a homogenized record and thermometers that have a huge warming bias. Now, this is the last slide. So again, I got back to where they're taking credit for cold records. Well, that's CO2's fault too. So here you have Greenpeace. This is no coincidence. The climate is changing. See what they're doing? Boy, you have all this cold weather. Negative 18.6, negative 25.4 in Spain. Okay, that's due to CO2. So not only do they say that heat records are the fault of CO2, but so are cold records, right? So the entire thing is craziness, it's lunacy. And that is why this whole thing is a hoax. This is the Cold War sailor out.